Hello, everybody. So welcome to our Affirmative Action for Algorithms webinar that Women at the Table is presenting with the 8+ Alliance. We're doing these webinars on the sidelines of multilateral events. We had one 2 weeks ago on feminist data, the UN Data Forum. Now here we are virtually at the Internet Governance Forum talking about algorithms. And we have an all-star panel for you today, which is very super exciting for me, and three of my actually favorite people, and I'm very glad that they've been brought together virtually. I'm going to redo their resumes because it's like too much to bear that they're all together with us. First, we have in the glasses Paola Villarreal, who is a self-taught systems programmer who since 1998 has worked and played with all things open in governments, NGOs, and the private sector. Currently, she's head of data science and engineering for the National Council for Science and Technology in Mexico. And has a lot to say about what's happening in the COVID world in that regard. In October 2019, she was named by the BBC as one of the 100 most influential women in the world. In November 2018, she was awarded an MIT Innovators Under 35 Visionary of the Year 2018 for her work at the intersection of data, science, and justice. She was also a fellow and affiliate of the Berkman Klein Center at Harvard and a Mozilla Open Web Fellow working with the ACLU of Massachusetts. She has a passion for open government and data, and we're so happy to have you with us, Paola. She's also an advisory board member of the A+ Alliance, and we're very, very grateful for her counsel. Also advisory board member and very good dear old friend is Elisa Celis, who's assistant professor in statistics and data science at Yale University and a co-founder of the Society and Computation Initiative at Yale. Her research, I have to read this because it's too wonderful, focuses on problems that arise in the context of the internet and its societal and economic implications. She approaches these problems using both experimental and theoretical techniques, her work spanning multiple areas, including social and computing, crowdsourcing, data and network science, and mechanism and algorithm design, with an emphasis on fairness and diversity in artificial intelligence and machine learning. We know that she has her PhDs in computer science and engineering, and her degree in mathematics, and she's most importantly a leader in the Latinx in AI movement, as well as the women in data science movement. And she was selected as one of the 100 brilliant women in AI ethics. And for that, we also thank you so much for being here with us. And last but so much not least is our newest friend, Nyalleng Moorosi, who I've come to whose conversations I've really come to cherish. He's a software engineer and machine learning researcher with the Google AI team, where she works on topics related to inclusion and fairness in machine learning. Before joining Google, she was a senior data science researcher at South Africa's National Science Lab, Council for Scientific and Industrial Research. And in her capacity there, she worked on projects ranging from rhino poaching prevention. Each of you deserves your own webinar, and sentiment analysis of political parties on social media. She's an active member of Black in AI and a founding member for the Deep Learning Indaba group. So thank you all, and thank you everybody. So you're all so amazing, and I think this topic is such a cutting edge topic, unfortunately not known by everybody in the world. So I'd really like to talk about how you came to your work first, before we really dig in. So I'm gonna start with you, Paola. How did you arrive at this in your self-taught journey?
Well, short version is that I started collaborating with governments, and I quickly realized that the best way to collaborate with civil society, governments, academics is through sharing data, right? So this was before the open data movement, this maybe 2005 and stuff like that. So I started to, share important data sets in CSV and creating tutorials to how to use those data sets in PHP or Java. And then it was, I was glad to see how many websites started to use, for instance, the zip codes that we have shared with them in Mexico. So that's when I realized the importance of data, even in these very, not so important data sets. But then I started collaborating with, fast forward 10 years, I started collaborating with Mozilla and the ACLU, and they shared with me several data sets, including one for stop and frisks in Boston, which I mapped out and analyzed it. And we quickly found that even with the police data that is supposed to be, in favor of the police, the racial bias was super obvious and quite visual, right? So I started to think that to read more about intersectionality, and of course I'm a feminist, so I wanted to include these perspectives into the work I do with data and justice. And that's basically how I arrived in this intersection of feminism, inclusivity, and algorithms. And my work right now is to, I have access to a lot of data, and I am also all the time worrying about who we left behind, like who the data we create, the data we use is not representing. So I'm trying to minimize, the underrepresentative of very important groups, especially in Mexico. So that's how I came to this.
That's wonderful. Thank you. Thanks so much. And really interesting, I think, too, how you went from being outside the system, but have been able to bring your really cutting edge techniques inside a system to really sort of help improve what's going on now. That brings me, I'm going to skip over now all the way across the massive pond, whole hemispheres over to Nyalleng. And just in terms of this journey that's landed you at Google, but also your data and Rhino poaching.
Oh, yeah. So the Rhino poaching, let's see, that work, like I said, I was doing it in the at the South African Research National Lab. So it was a bit of a long story getting there. But one of the reasons I joined that lab was because it had this nice intersection between public service. So you were kind of like a government employee, but then also you could work with industry and especially startups. And I think it was all part of that mandate of, your job was to help either the government or the people of South Africa do something better in whatever capacity you were employed in. So the Rhino poaching project actually came in from through some colleagues. So the CSIR is like this huge campus, of course, like other national labs, just this huge campus with like different people all over. And one of the buildings or one of the research areas is like security. And so we had some colleagues we were in the modeling and digital sciences. And so, which is just like, was just a bunch of like doing a lot of data science. And so they came, the guys who were doing security, and they had a relationship with the park rangers in the biggest actually, park in South Africa, which is the Kruger National Park. And that was around 2015, 16, when rhino poaching was really, really bad. Like you hear about it now, but it's actually gotten a little bit better. It was really, really bad around then. And so, yeah, so that was a really great project, which I mean, we did have an impact because, so our job there was to try and predict where we think poaching is going to happen. And it's not just us, it was like a whole collaboration of people. And through all those resources and all those collaboration, actually poaching did fall like in the Kruger. Unfortunately, what happened was that poaching moved from the Kruger to other places. And so the lesson I think for me there was that sometimes these problems are not technical problems. When you are living in South Africa and, you know, there's all this like income disparity and stuff. So I think the biggest lesson there was to, even before deploying a technical solution, try to understand the ground and the world at which this problem lives. Because I think that was a problem of poverty, or that was a problem of, you know, of demand and supply, because this was a product that was being demanded. And so we simply made it harder to get, and we increased the price of rhino horn, and that meant that more people were willing to risk going to jail for it. But anyway, it was also like an interesting thing about the prioritization of certain people who come into like a community. So we were the people who came into the community, and we decided that this is a problem. But then I think for people who lived around that park, for some of them, that was a way to make a living, and they were not, like, their prioritization was not conservation. But anyway, so that was that. And then I think as you introduced me also with like sentiment analysis, especially using social media data, I think it got to be quite clear for me that it got to be quite clear to me that, you know, there was a lot that was going on there that maybe we don't see. So issues like privacy started to pop up, issues of consent, because we were mining people's data and they didn't exactly sign up for their data to be used like that. And so I think for me, that's when I started getting into these matters of fairness and inclusion. And then finally, in our building up the deep learning endeavor, one of the big reasons we set it up was because we wanted to be contributors to this technology. We knew the technology was coming either way. I mean, we in Africa have received so many technology that came from the outside. This was a technology that was just starting. And so, but we could already see that there would be problems. I think when you live in a country with as great diversity and disparity as South Africa, you quickly, you know, there's going to be some groups that are going to be captured, and there are some groups that are not going to be visible in the data set, or they're going to be misrepresented. So our formation of, for example, this thing was to train people about the fundamentals of machine learning, like extend this knowledge so that people know what is possible, what's not possible, what is suspicious, you know, which users are like should immediately just like ring a bell in you know, in your head. And so, yes, I think all of these things, you know, all of these experiences made me start to think quite differently about the science. I still love the science, but it made me quite think and expand it out to, like, you know, where the science lives and the people it affects and how we build it and the problems we choose to build and where we choose to test the problems and all of these things. So yeah, and so when Google opened up the office, I wanted to join because there were Google resources to solve the problems that I'm interested in.
Super great. And I think that that also draws a line we're going to see of design justice, which is something that you all practice and all think about so much, and resource allocation and how these things play themselves out in the actual tech. But before we get there, Elisa, I want to ask you how your work in fairness started.
Yeah, sure. It's been kind of a winding road, I guess. So I was pretty classically trained in math and computer science, specifically theoretical computer science techniques throughout my PhD. And I was always interested in kind of models of human behavior and interaction between people, but it was very much from a mathematical focus, very abstracted from the real world. Whereas in parallel, in my personal life, I was also very involved in kind of volunteering and participating in intersectional feminist groups and in a big Latinx community at my university. But these were kind of separate worlds for me. It was my academic world and my kind of personal social justice interest world. And after my PhD, I went to Xerox Research. So I was there for a couple of years, and I started working. That's the first time I started really working with real data. So I was heading up their crowdsourcing research team, and of course, everything there. We were looking at data, we were looking at machine learning models, we were trying to develop these models and learn from people and get people to give us information with various incentives and whatnot. And it just became so incredibly obvious to me that the data that we were getting was so skewed. It was just a particular kind of people or particular kinds of opinions, and even the mechanisms that we were designing to solicit this information was already kind of begging the question, right? We kind of knew what we were looking for and what answers we wanted, and that the whole mindset from the beginning of the design, which was primarily thought of as again, this just kind of very technical, very theoretical model that we're just trying, and then somewhere we plug in some people. That's not really how it works. It builds in the whole system or whole viewpoint, and then just fills it in with data that again is skewed based on where we're pointing our lens, right? Where we're searching for this information, or even who has the ability to give us information. So that was a very kind of profound wake-up call for me, I think, at that time, making all of these realizations and really seeing that these two aren't separate worlds, right? This kind of nice theoretical box where I had kept my computer science and math knowledge was not any separate from the rest of the world in general. And not something that I could really separate. Working on that was not something that I could separate from my other values. So after some time, I mean, I had a great time there. I really learned a lot, but after some time, I realized I wanted to really spend my time and energy focusing on these kinds of problems. So that's when I decided to move back to academia. And that's when I went to EPFL, and that's where I got a chance to meet Caitlin when we were both in Switzerland, and lots of other amazing researchers. So I was at EPFL for a while and was able to start looking at these problems. This was around 2014 when the fat ML community really started taking off. So there started to be a wider community of researchers around the globe who were really interested in these problems and making steps. So that was a really exciting time to be able to really focus on it. And while I do think we were able to solve a lot of interesting problems, we worked, for example, in the canton of Valais on an election process on how to design fair elections when they're selecting committees so that everyone can be represented in the committee that's elected. And there are lots of interesting problems. I also, as Nyalleng mentioned, it was also very clear to me that this is not solely a technical problem by far, right? It's a society problem. It's not something where, although technology has a role, you're not going to fix this just with technology. And so a couple of years ago, I got the opportunity to move to Yale, where I've been for the last almost 2 years now, I guess. And here it's been really great to be able to expand my circle of collaborations. We have a bunch of collaborators at the business school, at the law school, in political science and psychology. So we can really start taking a more interdisciplinary approach and view the problems from a wide variety of angles. And that's what we've been trying to do with the Computation and Society initiative, where we bring people from a whole bunch of perspectives and a whole bunch of backgrounds together to help try to tackle some of these big problems without any sense that, okay, this is just any one angle is going to solve it all. So trying to take all of the building blocks together to try to design systems, understand systems, and understand where we can make the most impact, whether that's a technical solution or a completely non-technical solution.
Right. So this whole multidisciplinary idea, I think, is something that we'll keep returning to. And indeed, I think that the people who will be listening to this will be people who want to have a primer and want to start digging deep into this area without necessarily being technical. So let's just begin, just very briefly, just to make sure that we have a baseline here. It's like, what are algorithms and what's automated decision-making, Elisa?
Sure. So an algorithm is just a process. So if anyone who's ever cooked anything has followed an algorithm, right? It's just a step of instructions. You do this, and then you do that, and then you do this, and then you do that, right? So that's just, I mean, that's an algorithm in the most simplest form. But really the kind of algorithms that we're talking about today are what are called machine learning or AI or automated decision-making, where in addition to this mix, there's data. So there's information that you are taking. You've either collected it, or or there's some big data file that you've looked at that contains information. So, for example, we have data sets, like the internet is, you can think of as a big data set. So when you search something on the internet, there's all the web pages and there's information about those web pages. How many words are there? What kind of, what language is it in? What is the reading level of the language? What images are there? And then also other data as in when was it created, or who created it, or who does it link to, or who links to it, right? So these are all just pieces of information about data. And then the algorithms that run on top of this are what we call learning from it. So they're taking this data, they're taking this information, and they're trying to make generalizations. They're basically trying to make the same mental shortcuts that we make when going through life. So they're trying to, again, in search, trying to understand which of these are high quality versus low quality web pages. And you have your own internal algorithm. Actually, when you see two web pages, you have your own kind of gut reaction. Oh, this looks like a high quality web page, or this looks like a low quality web page. You can kind of think of these AI algorithms as doing something very similar. And these automated decision-making systems, they're just taking these same computerized version of our gut reactions, given all of this data that they've seen, to make predictions, right? Or to take decisions in terms of which search results are you going to show when someone searches, but then also in all kinds of other areas, as I'm sure we'll get into, where these systems are used.
Right. And so just taking it down the line a little bit, Nyalleng, just where, certainly in your work, but where are the algorithms used, and why, why are they important?
I think actually Elisa there, where she said pretty much anywhere where we try to generalize. If we're going to try to, if we think there is a pattern there and we are going to try to generalize and be able to predict it, we try to use these algorithms. Sometimes very poorly, we try to use them in very poor conditions, sometimes not so poor. So for example, these algorithms are used in diagnostics to detect which cell is good, which cell is malignant, which cells have malaria, which ones do not. We use it in a crop diagnostic, which plant, which leaf has this. We use them in hiring. There's in trying, even interviewing people. We try to figure out who's a great. We try to figure out who's a great candidate. We use it in who deserves treatment at the hospital. Use it in which student is paying attention in class. People have tried to use them to detect if somebody is a criminal just by looking at their face. And I'm saying all of these. I am not saying that all of these are good places to use these, but I'm highlighting them to show just how vastly we have deployed these algorithms. So pretty much anytime a human being says, I can spot a person, I can spot a pattern, then they think that you can also use a machine learning algorithm to do that work for that. But overall, these algorithms, I think what they're good at is that they can condense a vast amount of data into shapes and spaces that we can comprehend so that we don't have information overload. This is what they are good at. But yeah, where we deploy them, we really do. I mean, whether deciding if you should get a house, you should get a loan, you should, all of these things. They are just really everywhere. And I think this is why we want to make sure we're keeping an eye on it, because you think there's probably somebody who started to build a machine learning algorithm for it.
Wow. Okay. So we're going to get back into the notion of fairness at the core, but I think we're going to go take one turn of the table before we get there. And just because you've done such an amazing job, both of you, setting this up, let's just end it with, how are governments using this? How do these algorithms manifest themselves in the work that you're doing, Paola?
So not in my current position, like we are trying not to, because I agree with Celia and Nyalleng, Elisa, I'm sorry, and Nyalleng, that the problems we're trying to solve, at least in the government of Mexico, are not only technical problems. Like we are trying to also tackle the social part of these problems and to understand it. So to do that, you need to do a lot of exploratory analysis of data that is collected by independent organizations inside the government, like socioeconomical variables and stuff like that. So, but as also Nyalleng mentioned, like these algorithms are currently being used by a lot of organizations and are affecting millions and millions of people's lives, including in Mexico. Like right now, we are deciding who gets to obtain a credit, who gets to obtain a home, maybe, you know, like who gets a job, who gets social security attention, etc. Like, and also both Elisa and Nyalleng mentioned, and I agree with them, that in this, in the current state of these technologies, we are not putting it to the best of its use. Like we are trusting these technologies quite a lot, and that's something that we need to take into consideration for the future.
So how, where and how does the bias creep in to
it creeps in many places, I think, like even in the data collection phase, like it matters who collects the data, right? And which perspective they are collecting it from. It matters who uses the data or who cleans the data, right? Like who processes it, and maybe they have in mind a very specific data set they want to put it, to mix it with, and that creates a bias. And then also who asks the questions that this data set is trying to answer, or the analysis from these data sets are trying to answer. So if you are a white person from the city, you have that perspective, and it's very hard. You will need to be a very empathetic person to include different perspectives from, like indigenous people in Oaxaca, Mexico, right? So that's super hard to do, and because it is very hard to do, it's almost safe to say that if you are only asking, like if only one person is asking those questions, the answers and the data you get from those answers is going to be biased, right? Because you're only incorporating one single perspective. So yeah, it creeps in many places.
So just to, again, we're going to draw a loop here. So Nyalleng, where do you see the bias creeping in, or
Okay. So I mean, Paola is totally like all the way there. It's in the whole process. It's in the whole process. It's in the data collection. It's in the type of model you're going to use. It's and the kind of things you're going to do to that model. So, for example, we just did a paper not too long ago showing that if you go ahead and compress models, which is something that's very useful, but once you do your compressed model, it actually changes who is in and who's out, like who you see and who you don't see. And actually that then also goes to the next step about like how bias creeps in and gets perpetuated is the kind of error we're willing to tolerate and how we measure goodness of fit. So for example, one of the things we realized was if we continue on dwelling only on accuracy, we are missing so many other aspects of an error or so many other aspects of goodness of fit. Like this means like how good is this prediction for the problem that I'm trying to solve? We're forgetting about historical things that are underlying there in our data. And yeah, so all of these kinds of spaces, I think, there's a lot of work that is like both technical and non-technical that goes into this but fundamentally it's all about who do we see and who do we not see. And I think this was like Paola's opening statement, that so much of this is who we see, who we are tolerant of not seeing, and who we go all out to make sure that we collect this, we correct things, because there's always things we can do to these models to make sure that they don't make mistakes on areas we don't want them to make mistakes on. And so that choice is another place where bias creeps in.
So just to bring that down the line to Elisa. When we're talking about the bias, but we also talk about fairness, and fair to whom, which I think is always a really interesting question. So,
yes, definitely. I mean, I completely agree with both Paul and Nyalleng. I think these are some of the crucial areas from the moment you have that data, where and how it's collected. And then, as Nyalleng was saying, in terms of basically your metrics, how you're determining if a system or an algorithm is doing the right thing or not, right? Because that's a choice, right? You get to choose what it means to be a good algorithm, right? So certain choices will benefit some people and not benefit other people. And I think just to add one more step kind of internally in the algorithm, I think Nyalleng mentioned this as well, but in terms of your model choice, or what's sometimes called an objective choice. So that's basically, what are you telling your algorithm to optimize? Right. So what in the internals of your system, how are you encoding something? How are you imagining a good outcome, and how are you measuring that? Because you end up with very drastically different outcomes depending on what you want to measure. So if we go to, for example, a loan case, right? So say you're predicting who you should give a loan to. Now, what exactly are you optimizing? Do you want to optimize so that you get the fewest number of defaults? Or do you want to optimize so that in the end, your bank ends up making the most money? Or do you want to optimize so that, conditioned on not losing money, the most number of people get a loan, right? These are all three very different ways of looking as to what do we even want to do to begin with, different ways of framing the problem, and they have very different results with very different impact on people.
Yes. I was just listening, rapt. I think what I think is really interesting about that, it may not be so clear to people who are not thinking about this issue all day long, is that you can have that many, that you can't be, all those three things that you just described, which was a fabulous description, cannot coexist. They can't all exist in the same moment, in the same mathematical equation. And that is the problem in a way. So this idea of fairness, about that you can't be fair to everybody all the time in all ways, that you have to choose how you're fair, is part of what you were saying, right?
Right. So in terms of these three choices, I can't maximize all three simultaneously. I can perhaps balance across of them, so any one of them doesn't get too out of line. But I can't say I want the best of this and the best of this and the best of that, as in anything in life, right? We can't optimize all possible parameters. We have to choose at some point what is important to us. And as you were saying on the fairness side, that's a very similar concept, in which there's different ways in which we can measure fairness. So again, we can think about perhaps the most simplest one is notions of fairness that are easy to see how they're not compatible, are notions of representation. So do we want, for example, if we're looking at the loan example, say we have two different groups of people. Now, do we want, when people apply for a loan, do we want to make sure that we have the same percentage of people getting a loan from each group? Or perhaps do we want that the same, that proportionally to their application rate, they're equal in terms of what percentage of people who apply get a loan, right? So these are two different things. And unless you have the exact same number of people from each group applying, they're going to end up with necessarily different results, right? You can't have both.
So this definition of what you want in a model, this conversation that because we know that there would be policymakers who are listening to this conversation that policymakers need to have with people who are designing the algorithms about what they want the outcomes to be. And also the idea that we have a lot of assumptions. And we need to interrogate the assumptions in order to create the best models. And one of the ways that we're also seeing that is in social protection, where we know that a lot of models about welfare systems now were built to optimize not having fraud, as opposed to built to optimize quality of service. Well, of course, nobody wants fraud, but fraud not being the highest thing on the list, whereas quality of life being. And so those are, you have to really dig down deep and have this conversation. So all of you three are working in different ways to try and take the bias out and looking at different kinds of fixes. So I'd like to ask Paola about ways that either you're observing or you're using yourself, of ways that seem promising to sort of get the bias out of the algorithms or the process.
Yeah, I think one of them is, for instance, in the National Council for Science and Technology, we have contact with a lot of researchers from social sciences, right? And they do one thing that I really want to implement in like data gathering, which is they go to the actual places and they try to build samples that are representative of the population they want to research, right? But they not only do that and stay like that. They, like what I'm trying to say basically is that we should incorporate like social sciences practices in data collection in our more technical and more engineering work, right? Like, because I think we lack that perspective. Like we are not connected to the ground. We are not connected to the people who are making this, or we are not connected to the people our algorithms are making decisions for, right? And I think that's basically what we should do. Like we should be on the ground. We should, for instance, I work with, like my team works with the National Commissions for the Disappeared. And I'm trying to bring like data scientists to the searches, right? Like they need to be able to connect what we are developing, which is super important and very technical, and uses many very cutting edge algorithms. But they need to connect that to the ground, like to actually remove dirt and like find bones. So they can gain a perspective from these experiences and to see who they're looking for, like the mother of a person that is disappeared, who is also there looking alongside you for their son, right? So I think we need to incorporate those type of practices, like social sciences, which have been forgotten for maybe a generation of neoliberalism. Like they are super important, and they have a lot to teach us in this aspect of basically data sampling and data and sample building.
Okay, so this is, again, we're coming back to the theme of multidisciplinarity, which I couldn't be more in favor of. I know we all are. Nyalleng, can you tell us also on the technical or the design end some of the things that you see promising in the debiasing process?
I mean, I think there's a lot of really amazing work in auditing and debiasing and like really good technical work. And like I said, I've been trying to contribute into this area too. And then obviously like Elisa does so much of this work. But there are actually two papers recently that I have read that really jolted me. One was a paper that was written by Rediet Abebe and her collaborators. So she wasn't the only one, but it was about the roles of computing in social change. It's a really quick paper to read, but it was what it did is that it crystallized the problems that we have. It crystallized the issues, why we actually even see more of these problems now that we are deploying computation to handle social problems. So I think the biggest thing I took from that paper is we are trying to solve social problems with automated decisions. There are things that are embedded inside the data And there is a whole social dynamic, a whole history that is embedded in that data. And even in the methods and the methodology of which we go about this analysis, there are all of these things that are embedded. When you write code about something like that, you have to be explicit. And so you have to make these choices. This is like some of these choices we're talking about. And the moment you have to do these choices, then you have to acknowledge that you are going to do something for others and not for the other group. And I think for us in machine learning, it's so important for us to recognize that we are drawing boundaries about who's in and who's not in. And we are making those boundaries explicit. It's no more fuzzy the same way that like a human being makes the decisions. Ours are very, like, we are intentionally doing so. And I think if we think about this paper, this is what computation gives us. It gives us this power to audit the decisions that we have been making implicitly. And now we are forced to acknowledge that explicitly that there is bias in how we police. We had to, like, these algorithms, these discussions have been going on, but these algorithms gave us numbers of like, this is in this data set, this is how much this bias is, this is my skew. So that's the one paper that I really, really, I love. The other one was, it came out not too long ago. It was about decolonizing AI. This is a paper that is, written by a couple of researchers in the UK, I think DeepMind, and possibly other places. But anyway, and their focus there is about the embedded power structures that are in these algorithms, how we have these algorithms and we perpetuate these power structures, and how we need to be aware of this. And so they highlight things like who is creating the data, this idea of these ghost workers that we never see, who go through and clean up Facebook data for us, or clean up, Google data for us. All of these companies, go through and clean up the data, relabel our data set so that we have nice data set we work with, as machine learning people, where we run like beta testing. So for example, they gave an example of Cambridge Analytica having run their beta testing in Nigeria and in Kenya. And before they then deployed it in the UK and in the US, and actually also about how all that was allowed to be fine. That was all good and fine until they caused problems in the US and in the UK. Then, the antennas went up. And I don't know yet about, I think this problem is so difficult, right? Because like we said, you can't be fair to everybody, right? So it's very difficult to ask engineers or researchers to implement the perfect fairness score. And so I am of the firm belief that what we need is this ability to question and audit always. It's just about, we need to audit this, we need to highlight the possible problems that may be occurring so that people feel empowered and so that people are aware that these sorts of things can be problematic. Not all the time, but that they can be problematic and can affect them in this. So these two papers, I really love them because they have put it in a language that is so on the ground and took it outside of the computer and made it about our lives and about the history we know has always been there and the history that we are witnessing now through these algorithms.
I'm ready to end. I don't know where we go from there. I just absolutely, totally agree. Both those, I think they're both by Reddy Abebe. One, the Decolonizing AI, I know is by her. So we're going to have her in conversation with you shortly, I'm sure. Are there, Elisa, just taking this to keeping it in the social realm, but also looking at the technical, are there things, different ways, like audit systems that you like, or different kinds of ways of conceiving these models that you like, that you think have some promise that will help us a little bit more?
Yeah, definitely. So yeah, absolutely, to everything you just said. I completely agree. So having those conversations, talking to those who will be affected, that's crucial. But to speak to your question, Caitlin, as to now that we know, or at least we have some ideas to what are the technical things that we would want, and then it is also important to have those tools. So sticking to the technical side, again, this is not the only step, or certainly not even the first step, but once you've kind of narrowed it down, now the question is, what can you do technically, right? And I see it, I generally think of it as kind of three different places in the pipeline where we can step in to intervene, where we already have a good set of toolboxes, a good set of tools in our toolbox, from from the fairness AI community. So one is at that data step, right? So even so I'm even now focusing on the stage where we have a data set. Ideally, you thought about this very carefully beforehand when you were collecting it, and when you were cleaning it. All those steps were very carefully thought out. But now we're at the stage where we have that data set, and no matter how carefully you did things, there's probably still bias in there. Right, so there's an increasing number of algorithms. This is actually some of the, from even 20, 30, 50 years back on, just looking at data biases and how to adjust them or correct for them. So that's one step. Before you even pass this on to an algorithm, right, look at that data, analyze who's in there, who's not, and then you can do things like oversampling or undersampling, and there's all kinds of different techniques to do this very formally in a way where you don't lose that quality of the data. We're not adding noise, we're not corrupting it in some way, but we're making sure that everyone we want to represent is seen as much as possible, right? So that's one step. Another step is what we sometimes call in-processing techniques. So that's the step when we're looking at the model, right? We're looking at the model itself. We're perhaps placing constraints on the optimization steps of our algorithm so that we don't let it skew too far in any one direction. This is basically translating those common values that we have agreed upon through this interactive process into one or more fairness definitions that we now want to balance. And there are ways of basically writing those in a formal language and building them into our model. So again, we don't let anything suddenly get really skewed in our optimization process. And then the last one, which is what's often called post-processing, is once you have that whole thing built, either if you're designing it yourself, or as happens very often when we're using these basically black boxes, either trained by any one of these big companies, Google or Amazon or one of these, often, especially kind of small businesses or even governments who don't have that those technologists to build new systems themselves, what they do is they take these things off the shelf, right? So if I take it off the shelf, hopefully I'm doing my due diligence and finding companies that have already done the work to provide good models and good algorithms that can be tuned to my particular setting. But even if not, there's post-processing techniques that says, once I've made this prediction, it's almost like a mini audit at then. Once I made this prediction, what do I need to correct? What do I need to check for right then? And what decisions do I maybe need to flip from what the algorithm predicted because of the biases that I know exist, right? So you can basically kind of put an extra filter at the end. So there's this pre-processing of the data, in-processing, changing the model itself, or post-processing. Even if you took a model off the shelf, you can still do something at the end and to try to correct for all of these things. Again, these aren't the first steps to do, but these are all important steps to do, and they're all, and we have those tools, right? So I would, there's the FACT community that has this yearly conference. That's a good place to look for if you're searching for papers or techniques or different tools. It's a CS conference, but it's also interdisciplinary, and that's, yeah, if you have a particular problem, that's usually my first place to go search for technical solutions.
That's great. I think I'm good. At the end, I'd like us to go back to audit and talk about how much we're auditing and where we can do it and what tools actually exist there. Maybe, or I don't know if that's something that you can address now, Paola, in terms of the correcting for bias, whether auditing systems are in place or ones that either you're not using them, ones you wish existed. You'd like to use?
Yeah, I mean, I just want to mention one thing that Elisa said that is crucial for this conversation, which is, I mean, to reduce biases and also to audit the algorithms, right? Like, and this is transparency and openness. Like, we need to be able to know which data set they use to train their algorithms, and we need to be able to audit the code of the algorithms, right? Like, and because many of these algorithms are black boxes and are protected under the most strict intellectual property laws and commercial trade laws. So yeah, we don't have access to that. So for a government to use this type of algorithms, like black boxes algorithms, it's only, in my opinion, very imprudent. Like the governments and organizations that make decisions for millions of people's lives should not use black boxes to make those decisions. Like they should not, because they don't know how these algorithms were trained. They don't know precisely which biases they introduce. They cannot connect the dots to people that they are leaving behind.
Can I just ask you a question that I'd like to ask all of you? So if we all agree that audits are important, and let's throw aside that maybe people have signed contracts that don't allow for audits, but going forward, in terms of having contracts that might allow you to do it, how, if someone was going to take the position that like, oh, this is a trade secret because this is our, this is the secret sauce for our company, how would you see us going about audits that would still allow people to have their secret sauce, but still allow the public or governments on their behalf feel confident that they know what the algorithm is doing or where it came from?
I think it's risky. Like it's still very risky because, well, in one hand we have what Nyalleng mentioned, which is colonialism, right? Like many of these algorithms were built by foreign companies and are implemented in many cases, third world countries, right? So that's one part of the problem. Then like even if they implement these like like contracts that allow you to see training data and the code of the algorithms, that doesn't prevent from time passing, right? Like maybe this administration has access to that, but maybe the next one doesn't have access to it, and or maybe the federal government has access to that, but the municipal government doesn't have access to it, right? So to prevent that and to make it time-proof, and also to allow to like local people to build their own algorithms, we need to have open access to the training data and open access to the code of the algorithms.
Okay, I still want to hear about what the actual process of the auditing is, but that's a, I mean, we all agree here because that's our next work, right? Is to figure out how we get the audit system available and open for everybody. Okay, this is another conversation. I personally don't believe that we need to be able to look at the code. Like a person like me, it would be useless. But one needs to, the same way that when you buy a drug at the drugstore, you're assuming that some regulatory authority has said it's safe to use, and so that I don't need to know exactly what went into the Valium or the aspirin or the ibuprofen, but still there's some reasonable expectation that it's not going to kill me when I take it, or deny me a loan or whatever. So I think, you know what I mean? I think that there's probably got to be a way. We figured out to do it with drugs that have patents. Why can't we also maybe even do it for algorithms?
The doctor has access to that information, so they are making the decision for you. And right now, it's as if the doctors don't have access to the composition of the formula, because the medicine you're taking is a black box. So that's actually what's happening. So it's right. Using your own analogy, like it's as if doctors don't have access to what's in the pill you're taking.
Yeah, and that's exactly what we're going to work on changing altogether, because obviously it's not tenable. But I'm looking also for solutions for these policymakers that are sitting around listening, going, "Oh, well, maybe we could change it. We're not going to kill competition, but we can also make sure that we all benefit from the algorithms, right?" Which is also the point. I'm wondering, so so we want to go forward. We've identified what the problems are. What are some of the things that we might do in our particular spheres of influence to sort of create the environment to make things better, go forward, take the next step? Nyalleng, what do you think from your point of view, your perch?
Yeah, and actually, maybe I will also go back a little bit to this idea of audit, even if we are trying to audit black boxes. There's been a couple of people who have done work where they have given suggestions. So, for example, Meg Mitchell and Timnit Hebrew and a couple of other people have proposed things like data sheets for data sets and model cards for models. And these are supposed to be kind of like the nutritional labels that you're going to get on food, right? It's supposed to tell you that this is the data we got, this is the representation, this is how the data is broken down. And then also, like, so model cards is also supposed to do the same thing, but now it's for models. It's about documenting your model. This is how big it is. This is its failure modes. This is its success modes, and it was tested on these data sets and things like this. So that at the very least, you know, it's giving you something to work with. I think there's also quite a bit of work, for example, work that was done by Joy Bolamwini, and this is a different kind of auditor. This is just people who are sitting outside, and also Deb Raji was also part of this work, where they just took the commercial products that were accessible, and then they tested them on the edge cases, which are usually like the underrepresented populations. And then they documented that. So like that big paper on gender shades, I think it's called, but anyway, yes, it came out of that. It was just, Joy and, sitting in the lab and just like testing it out. So that's another way to audit, is to also like figure out, does this thing work for us? As researchers, also conferences are starting to ask that people include impact statements of their work. So that's another thing that can be made visible, to say, I think this is how my solution or my design is going to work, and I think this is where it will fail, this is where it will have success. But going forward, I think for me I think it's just still down this path of still doing some technical work. But then I think the biggest thing for me right now is just this activism. We need to activate people to be aware of how prevalent this stuff is, how prevalent these algorithms are being deployed, and to just question that. Like, I feel like this is the biggest thing for me right now, is to engage people. For example, you look at like people of the European Union, or the European Union as a governing body, right? With GDPR, they've really gone out there and say, we are going to get accountability for these tools. And I think something like that, for other people, for other governments, it doesn't need to be like state owned, but it just needs to be more. And you're starting to see it. You're starting to see people organizing themselves around what these algorithms can do, and how these are, like, for them, positive things, but also like negative things. But yeah, I think we will see where all this ends up. I really have no idea where we will end up with it, but at the very least, I hope we get better at documenting what's happening.
Right, auditing, impact statements for work. This great. We're gonna try and put everything in the chat, the data sheets for data sets, but you can also look it up. Also, the model cards, which was really, kind of fundamental work in terms of this kind of like basic audit from your colleagues in your group. Yeah, exactly. So taking this to the interdisciplinary point of view, Elisa, what is this environment? How do we create the environment where we make this kind of work happen and have it implemented?
So I think it's really important to be able to talk to people who are, for everyone from those designing policy, to those trying to write legislation, to those whose work is really on understanding humans, right? What people want, what societies want, what are reasonable structures that have had success in the past, what can we learn from the past, right? Let's not show up and try to reinvent the wheel. So that's where I really see this interdisciplinary. I really mean in the broadest sense, not CS talking to math, right? Which is someone close, but really people with very different backgrounds and very different perspectives on what solutions could look like. And I think that's it's just really important on in both directions, right? If we want to be able to design some kind of policy or design some kind of legislation that is going to mandate some open data, some open model, some process for auditing, we need to understand from the technical side what is possible, what we can do, what we can demand. And it's so important to have people in this area who are willing to spend that extra time, basically that free time, talking to legislators, talking to the ACLU, as I know you've been doing, Paola, talking to all these organizations who are doing that grassroots hard work, because it's otherwise so easy, as we've seen in many of these hearings, for these big companies to send people in to say, oh, we wish we could do that, but we can't, right? And then also to have people like you and Nyalleng sitting inside these companies who are already exploring all the things that you can do and seeing exactly how it fits into this huge machinery, right? Because we have all these tools, and I think only very recently have I started to see some of it come together from all sides. And we need people pushing from all sides. We need people inside the companies. We need those grassroots movements, and we need that new research so that we can all work together to get not just technical solutions, but technical solutions that work inside these giant companies, which we can also ask them and require them from the outside that, yes, these are important things to do, right? We need the citizens pushing governments. We need these organizations pushing governments to say, this is not something that we're okay with, right? This needs to change, and get that all the way through so that we get some change all across. And you miss any one of these pieces and it's not going to be a success. You might get some legislation, but it'll be empty, right? You might get people inside of a company really wanting things to change, but not being able to get the whole machinery change. So that's how I see it, as something really broad. We all have our specific roles to play, but we all also need to be talking to each other to make sure it happens as a whole.
So maybe it's unfair to punt this to you, Paola, but what do you think, if you have a magic wand at a government, what kinds of things would it be great for government to do? And what's hard for government to do? I mean, where do you need help?
So I think governments need to embrace multidisciplinarity and collaboration, right? Like in my experience in governments, we are trying to only do one thing that is appointed to you by law, and you cannot do anything else, right? So that basically makes our governments work, but also very slow to innovate. And governments are now using technologies that they are not prepared to use, right? Like they don't have the capacity, like the technical capacity to even understand what they're using. And that's a problem because they're actually making decisions for people. Like, I'm sorry for being repetitive about this, but you're making decisions for millions of people, and you don't know how to, like, what's involved in the decision making process. So I think we need to embrace multidisciplinarity. I would love to see more social scientists work in the government in collaboration with data scientists and engineering. And let's not forget, please, let's not forget how important data engineering are. Because they do all the dirty work that data scientists don't want to do. So I would love to see more collaboration with data scientists, social scientists, data engineering, politicians. Like, let's stop assuming that our algorithms are neutral and not political. Like, we are political, and the algorithms we make are also political. So let's assume that, and let's work with politicians and let's try to, like, from a technical perspective, let's try to collaborate with them and explain what these black boxes are doing, what these algorithms are doing, and how they can use the information that is provided by these algorithms for them to make politics and policies, right? So I think that's something that that is lacking in the government, and I would also love to see hackers in political spaces. Like, I think it's crucial for technical-minded people to do politics. But at the same time, I will be scared for a lot of technical folks to run a government. So it has to be like a mix of professionals. And I say this because I also think that we, as technical providers, or not providers, as technical people and technical, like we have a lot of power, and we don't have any accountability of it. Like, we can code almost anything, and we can lie with our code and with our data, and we don't have any accountability. And we have a lot of power, as we have seen in the elections, like 4 years ago, and in Kenya, and in South Africa, and in Mexico, and everywhere. Like, data and data engineering and data sciences are changing the world, and we are the ones that are changing it, and we don't have any accountability. So that's super, super important.
So that's a very interesting point, and especially coming from you. I'm going to give a last question to everybody, but I'm going to actually hand it to you first, Paola. What do you think? And you can take either end of this question. What do you think we need to do to help technical people understand that they have an accountability, and actually they're involved in politics, that they're not making neutral things? Or what do we do, how do we help policymakers get the amount of information they need to make intelligent, informed decisions without sending them back to graduate school?
Sending them back to graduate
start
school.
with that.
Yeah, that's a very hard answer, a very hard question to answer. And I will say, like, be involved in communities. Like, there's nothing more, like, I haven't learned anything outside of code, outside of communities. Like, everything I know, I learned in community. Basically, the open source communities and the open data communities, and, you know, like the social justice community and the activism communities and the internet freedom, etc., etc. It's all about communities, and you can learn from those, and you can teach in those too. So don't be a lone wolf. Don't be, like, you know, share your content and share who you are. Like, I'm also talking about culture here, right? Like, you need to be able to share who you are, what you like and what you don't like with other people. And what's very beautiful about the times we're living is that we can share that with people from all around the world, the globe. So that's super beautiful. But besides that, like, concrete actions, I don't know, like, to start losing your fear to do politics. I think it's super necessary, and you can see that if you leave the decisions to someone else, maybe that someone else is an algorithm, and maybe that algorithm is biased. So you can be left behind by an algorithm. So you need to take, like, people need to take that into their own hands, and to collaborate and participate in many communities and political activities. Sorry, this is not technical, it's more philosophical, but.
All right.
Yeah.
Who has that? I'm going to go with Elisa. Either how do we help technical people understand, or how, and also how do we help the policymakers understand? Because those are two different actions.
Sure. In terms of policymakers, I think just speaking to technical people, speaking to my core community, I think we just need to make ourselves more open and more available to have these conversations. I think that's just crucial, and it's not something that enough of us do. But in terms of how to help technical people, I think it is so crucial. Of course, there's huge communities of amazing people that are doing great work, like Paola, who are self-taught. But there's also a lot of people in a lot of these companies that come through our universities. And I don't think it makes sense to be teaching someone computer science without also teaching them something about the world, because computer science doesn't live apart from the world, right? So in my view, every computer science certificate or course or degree needs to include some introduction to what are the actual impacts in the world of this work, right? What are the actual things that you should sit down and consider before designing a technology? A computer science degree shouldn't just be about that design itself. It should be about everything that surrounds it, right? So I think that is really important. And there's a couple of classes at a couple of universities, but really it's not something that is considered core. And it needs to be, right? You can't design systems for people without understanding the effect it's going to have on people. So that is the biggest change that I think needs to happen within the computer science community, to make sure that moving into the future, we don't create these huge problems that we've been designing for ourselves.
Right. I agree completely. Nyalleng, what do you think? What do we need? How do we attack both ends of the spectrum?
Oh, oh, I've just been listening. I'm so lost in these ideas that have been shared. Thank you so much, both Elisa and Paola. When Paola said accountability, how we're not accountable for the things we create, it's actually really interesting. Like, not only can you not be accountable because you can say it was just a research, it was a curiosity, right? You've got your own research right to explore questions, but then also inside the company, sometimes a lot of the time the heat comes onto the company and not the researchers themselves. It's interesting. But I think maybe on this question of communication, I think so I completely agree with Elisa. Like, we have got to do computing with social aspects. I think I was fortunate enough because I started with a liberal arts degree. And so you're forced to do all of these things. You know, you have to do humanities and art and all of this stuff along with your computer science or math or whichever thing that you want to do. But I think one of the things that's, I don't really know how to communicate this, but one of the things we're missing out is this understanding from researchers or engineers that they are also citizens, and that there is this separation, you know, that the things we create, even if you don't directly create them for you, you're creating them for your neighbor. And so I don't know, maybe it is something about the hype of machine learning and the fact that people who are in this discipline are supposedly some of the smartest people. I don't know if it's part of that, either where we feel that what we are creating is beyond critique or is so objective or so, you know, all of this. Like, and I think that's one of the first things we have got to lose. I think we've got to lose this idea that what we are doing is going to always, you know, change the world for better. And I think one of the things, though, to maybe move towards that is that we've got to internalize the cost of these algorithms and the cost of the mess we create downstream into the process of computing. In the same way that we were able to internalize the cost of building systems that are not secure or systems that are not stable, into that. Like, you are not going to be allowed to release code that's not safe, that is not secure. You're not going to be allowed to release code that's difficult to maintain. And yet, you know, we are not as pedantic, you know, about like releasing code that doesn't generalize very well. Like, sometimes we don't even know if it generalizes very well out. So I think just doing this sort of culture, but then also this thing that we are doing where we are holding people accountable, and where we are actually making it count, to the researchers themselves. I mean, now we are starting to see even researchers write letters critiquing like a form of research where they are saying this is bad science, it needs to be thrown out. I mean, all the work that has happened with facial recognition, right? It started from, and I think that sort of stuff, I think we are moving in the right direction. I feel like I'm throwing in a bunch of papers here, but there's actually, for people in computing, there's one that's written by Ben Green, and it's called Data Science is a Political Action. And it links exactly like what Paola also said, say, if you leave it for somebody, it might be done by the algorithm. So in fact, if you decide you're not gonna put your hands into all this fairness and inclusion and diversity and all of this kind of work, you are still making a decision and you're still making a political statement nonetheless. And I really loved so much what she said with that. So yeah, that's where I'm at.
Well, there we go. We could talk for a very long time, but I promised everybody that this would be short and sweet. So we are at the end of our time. I mean, I do think that there were a couple of themes that everybody seemed to really be teasing out in very, very different multidimensional ways. One is this interdisciplinarity, multidisciplinarity, how we're all going to work together, how we're going to bring bodies of knowledge to the work of the computer scientists and data scientists to sort of make it richer, fuller, fairer. Then the idea of accountability, right? Whether we call it an auditing the algorithms, or we talk about accountability for the actual makers of the algorithms, or the buyers of the algorithms, or the subcontractors of the algorithms, which are what governments are now. Really, how do we make these things safe and open, and how are we able to interrogate them to make them better and better? Because it is an iterative process. And I do think, sort of half in closing, there's a t-shirt in something that, well, there are t-shirts in what all of you said, but I think, Paola, you're going to get the t-shirt from this particular thing. Is like, if you leave the decision to someone else, that someone else may be an algorithm, which I think is just totally like, we're going to be wearing that now too. And I think those are fighting words and good parting words. And really looking forward to continuing the conversation with all of you. All of you in the audience are brave and mighty people. We'll keep on talking, and we'll work on making a better world all together, sort of one algorithm at a time. So with that, we'll say goodbye, wherever you are.